In this video, we are going to explain you everything about geomagnetic storms. What is a geomagnetic storm? A geomagnetic storm is a major temporary disturbance of the Earth's magnetosphere, our planet's magnetic field. It is caused by an exchange of energy from the solar wind into the space environment surrounding Earth. The most powerful storms are usually triggered by a coronal mass ejection, which is a massive burst of solar wind and magnetic fields released from the sun. When this magnetized plasma cloud hits Earth's magnetic field, it causes the field to rapidly compress and change, resulting in a storm. Are geomagnetic storms visible? Now let's talk about the aurora. What is that exactly? The most visible and geographically striking effect of a geomagnetic storm is the intensification and expansion of the aurora, northern and southern lights. The aurora typically occurs in the auroral oval, a high-latitude band surrounding the magnetic poles, northern Canada, Alaska, Iceland, and Siberia. What is the effect of the geomagnetic storm on the aurora? During a strong geomagnetic storm, the increased energy entering the atmosphere causes the auroral oval to expand toward the equator. This is why the aurora is sometimes visible in countries at much lower latitudes than usual, United States, Central Europe, or even as far south as New Zealand. You can learn more about this as the quiz named Earth's Magnetosphere. In this game, it is visualized to you how the magnetic field of the Earth protects us from a coronal mass ejections. You can play the games at Purpose Games. Find the link in the description of this video. What are the impacts on infrastructure? The rapid changes in the magnetic field during a storm induce electric currents in the Earth's crust. These currents have major geographic consequences for human infrastructure, particularly in high-latitude regions where magnetic field lines converge. Geomagnetic storms have consequences for electricity grids, satellite systems, pipelines, radio communication. What are the consequences and effects on electricity grids? CMEs have an enormous effect on long-distance power lines, especially at high latitudes. That is due to geological conductivity and magnetic field alignment. The consequences are that geomagnetically induced currents, GICs, can overload and permanently damage electrical transformers, leading to widespread power blackouts. What are the consequences and effects on satellite systems? GPS, communication, and weather satellites in orbit are affected globally. One of the big consequences is that increased atmospheric drag on low-orbit satellites and radiation-damage electronics. That is disrupting global navigation and communication. What are the consequences and effects on pipelines? Long oil and gas pipelines act as conductors. Induced currents caused by the CME event can accelerate corrosion in metal pipelines over vast distances. We will see more collapse of pipelines in the near future, especially on high latitudes. What are the consequences and effects on radio communication? High-frequency radio signals are absorbed in the polar and equatorial regions. What can happen is that there occurs interference or complete radio blackouts. Radio communication is critical for polar flying aircraft and maritime vessels. The greatest risk is concentrated in geographically extensive grounded conductors, making power grids in countries like the USA, Canada, Russia, and Scandinavia particularly vulnerable to the most severe storm events. Would you like to see what you have learned from this video? You can test yourself in a multiple-choice quiz that I've created for you. You can play the game named Geomagnetic Storms at Purpose Games. You can find the link in the description of this video.